going to open up, I don't know, something. And hopefully we can talk about this for just a second. QNAP RAID types. There we go. Let me also open up MS Paint. Okay. All right. So let's see, RAID type 1. Let's see what size we are. Let's make it a little smaller. Single disk. That's all it is. That's all you have, just one disk. Pretty much every computer or laptop has a single disk. Sometimes you can get away with like a RAID 0 or a RAID 1, depending. But yeah. Count 1. There's no fault tolerance. So you can only have one. I miss having Epic Pen, but they suck. So let's go back here. So this is single, so you just have a single disk. If we have JBOD, you can imagine we just have a bunch of disks. Oops. Disk fault tolerance, basically one or more. I think I did that backwards. But anyway, it's a combined disk capacity. Basically, it would be like a RAID 0, except you're not actually doing a RAID. So basically on a JBOD, it'll fill up one disk, and then it'll fill up the next, and fill up the next, kind of sequentially. So if you're doing JBOD, typically it's a sequential order. When we get into the actual RAID types, like RAID 0 and RAID 1, so let's see, RAID 0 is basically striping. It says you can do 2 or more, but I don't ever remember being able to add more than 2 in a RAID 0. I'm sorry, a RAID 1 is what I meant to say. So a RAID 0 is the same as a JBOD, except what happens is you have this thing called striping, and that'll be a major theme. So like as an example, if you write, depending on your node sizes, so you might have, say, 64 kilobyte size. So you'll write 64K here, 64 here, here, and then so forth. This is what they call striping. So technically you're putting data across all of the drives basically equally. This is really nice because, say, if you have like a 1 terabyte disk and you have 5 of them, this makes it so you have roughly 5 terabytes usable storage in the RAID 0. Keep in mind there's no fault tolerance, so if you lose a drive, your array is pretty much gone. You will be able to get back the other 4 terabytes of data. The problem is, if any of that data is striped over the 5th disk, that data is gone, which means you really can't recover. So RAID 0 is best for things like gaming. You want to have really, really fast read and write. Well, there you go. You'll have gaming for RAID 0, but if you really need to keep your data, it's probably not the best idea. In a RAID 1, this is a little different. This is something called mirroring. So basically, any data that you write to disk 1 will automatically be mirrored or written to disk 2. And then, of course, anything else you write to the disk is automatically going to be mirrored. This is actually really cool if you want to have, what do they call it, RAID 0 plus 1 or RAID 1 plus 0, I can't remember. But basically it allows you to read from both at the same time. However, there is a, what would you call it, write latency, because if you write to 1, you also have to write to 2. So if you ever lose a disk, you're still going to be up and running because the data is mirrored rather than, striped in a RAID 0. When you get to the RAID 5s and 6s, this one it gets a little bit more advanced. So as an example, we'll use 3 disks for a RAID 5, and I believe it's a minimum of 4 disks, for RAID 6. So basically this works kind of like striping, except it has what's called a parity. So parity times 1. A RAID 6 has a parity times 2. Now depending on how this works, you have the different RAID levels like RAID 3 and 4, which we're not going to really get into. But the whole point of it is say you have bit 1, bit 2, and then parity. So 1, 2, parity, 3, and 4. And then you have 5, parity, and 6. So you're technically losing a drive's worth of storage space or usable space, but it actually stripes the parity across all 3 disks. So you don't just have one disk with a whole bunch of parity. I believe that was in RAID 4 the way they did that. And keep in mind, this will really matter a little later down the road when we talk about RAID 50 and 60 and 100. The same type of thing occurs with RAID 6. So you have data, data, parity, parity. Parity, parity, data, data. Data, data, parity, parity. So basically, you're going to stripe the information across all your disks, but you're going to also have 2 parity nodes. So you might have the 64K here, 64K here, and then there's going to be a parity of both of these combined. That basically allows you to lose 2 potential drives and still function, like in RAID 5 where you can lose a single disk and of course still function. This parity is a parity of both nodes of data. So you have 2 parities of the data, which means you can lose 2 drives and still be functioning. Let's see. After RAID 6, we get into 50 and 60. So what I'm going to do is I'm going to clear this off really quick. And let's just create a new. So a RAID 50 has 6 or more disks, and a RAID 60 has 8 or more. So what we're going to look at here is, let's see, RAID 50. 1, 2, 3, 4, 5, 6. Over here we're going to look at a RAID 60 where we have 8 or more. 1, 2, 3, 4, 5, 6, 7, 8. Now keep in mind this is 8 or more, but one of the things you have to realize is how the RAID arrays work. In this case it's 6 or more, 1 per disk subgroup. So you have to think about how a RAID 5 works. In this case, a RAID 5 requires 3 or more. Because we have 6 disks, we basically have to chop this into 2 subarrays. So you're going to have a RAID 5 here and a RAID 5 here. This allows us to get our RAID 50. The same thing occurs with a RAID 60. You have 4 or more, even number required. Because you have 2 disks and 2 parity, you have 2 subarrays. So you'll have a RAID 6 here and a RAID 6 here. Well, let's read what it says. Multiple small RAID 5 groups are striped to form one RAID 50 group. Better failure protection, faster rebuild times than RAID 5, more storage capacity than RAID 10, better random access performance than RAID 5 if all disks are SSDs, recommended for enterprise backup with 10 or more disks. Okay, And keep in mind what it says right there. Recommended for enterprise backup with 10 or more. Multiple small RAID 5 groups are striped to form one RAID 50. So now, this can be a little iffy when you think about what does it actually mean. So, if you have two RAID 5s, you're going to have two separate, what I'm going to call, volumes. So you'll have volume A and volume B. Basically what this means is you have two separate storage arrays. When you put a share folder, let's just do SF1 in A, you're going to notice it's only in A. That's it. Over here you'll have share folder, let's just put 2. And this is going to be in B only. Now we do have the ability to run sync or replication. That way the shared folders can replicate between one another in either semi-synchronous real-time or asynchronous, which is not real-time. When we look at a RAID 50, this is going to give us one volume. The same thing with RAID 60, you're going to have one volume that stretches across multiple subarrays. So let's see, one disk per subgroup. Now this is where it gets a little iffy. Multiple small RAID 5 groups are striped to form one RAID 50. So there's the question that I have about how RAID 50 works. My thought process is it works exactly like RAID 5. Stripe, stripe, parity, stripe, stripe, parity. And then it goes parity, stripe, stripe, parity, stripe, stripe. Stripe, parity, stripe, stripe, parity, stripe. So basically it contains all your data amongst both subarrays. So the entirety of your data is going to be across two different RAID groups. So you don't have a single RAID group with data and another RAID group with data. The data is going to stripe across both subarrays, creating a single RAID 50. Keep in mind, this is why they don't call it a RAID 51. Because a RAID 51 would technically be stripe, stripe, parity, 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 parity. That would be a 51. Because you'd have a RAID 5 here, and then a mirror over here. Let's make this a little easier. Maybe it'll make more sense if I do it a different way. Bit 1, bit 2, a parity of 1 and 2. Bit 1, bit 2, a parity of bit 1 and 2. That would be a RAID 51, because if you remember, a RAID 1 is a mirror, not a stripe. So that's what I think that RAID 50 and RAID 60 do. You have data, data, parity, parity, data, data, parity, 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 parity of data, data, parity, parity of data, data. But what you're going to get from this is we have a single parity per subarray or a dual parity per subarray. So with the RAID 6 and 60, you're always losing 2 disks per subarray in usable storage. So basically what I'm telling you is if you have 2 RAID 6 subarrays, you're losing 4 drives to parity information. In a RAID 5, in this case RAID 50, you're going to be losing 1 per subarray. So in this case, which one should we choose? One of the last things we do need to talk about is RAID 10. Now RAID 10 is a little different because we're not talking about RAID 5 or RAID 6, which were parity RAIDs. In this case, we're talking about a mirrored stripe. So in my array, I have four 4-terabyte SSDs. Now you may think to yourself, you have 4 disks. You can do a RAID 10 with 4 or more, but you can't do a RAID 50 or a RAID 60. You could do a RAID 6, and you could do a RAID 5. Now in a RAID 6, I will be doing, data, parity. So I'm losing half my drives. Let's see, with a RAID 5, data, and a single parity for the other 3. Now this is really nice because, okay, with a RAID 5 I can lose 1. With a RAID 6 I can lose 2, and then I'm going to keep my data. Or I can do, a single, a JBOD, and have, a single or 4 random disks just sitting there with 4 different volumes, or a single large volume. Or I can do a RAID 0, which basically allows me to have all 4 disks usable. So if we come over here on a RAID 0, I'm now going to have 16 terabytes of space because I have a RAID 0 of 4 4-terabyte drives. That sounds pretty neat, right? I have 16 terabytes of usable storage. They're all SSDs. It's going to be really, really good and really, really fast. The same thing can, of course, be said for RAID 10. RAID 10 is a little bit different. A RAID 10, if we come back and find that, 4 or more, even number required. 1 pair of disks, total number of disks divided by 2. So like a RAID 6, in this case, I would lose half my storage. Now keep in mind, if I had 8 4-terabyte drives, a RAID 6 would still only lose 2 of them. Because a RAID 10 is total number of disks divided by 2. If I have 10 drives in a RAID 10, I'm losing 5 of them completely. So every 2 disks are paired using RAID 1 for failure protection. When all pairs are striped together using RAID 0. I mean, to me that doesn't make a whole lot of sense. Every 2 disks are paired using a RAID 1. Okay, so this is going to be a RAID 1 right here. This is a RAID 1. Basically, a RAID 1 is a mirror for failure protection. Then all pairs are striped together using RAID 0. So this over here is also going to be a RAID 1. However, I'm going to stripe data across 1 and then 1. And then I'll have a mirror. So you got to remember, this is not parity. This is a mirror. So when I have byte 3 and byte 4, well, that will be mirrored onto the other 2 in a stripe fashion. So this has excellent read, write, and high failure protection, but half the disk capacity is lost. So once again, this is one of the questions we have to have. This was my 4 4-terabyte SSDs. Those are going to be for my virtualization. So if I have virtualization running, I want to make sure that I have excellent read and write speeds and, of course, high failure protection. With RAID 5 and RAID 6, you have a write, a write penalty, because it has to take all of those writes and then compute a parity based on that data. So if I have 3 disks with data and a single parity of all 3 pieces of data, which can get messy when you're looking at computation. With a RAID 10, it's simply a mirror. There is no computation that needs to be done, so basically it just mirrors it in real time, and it gives you, a really good write performance. I can't do 50 or 60, so basically I'm limited to a RAID 0, 10, 5, or 6. In this case, I went with 10 because it's virtualization. Now, if we look at another item, in my QNAP, I have 12 disks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. I have 12 drives. I have 12 14 terabyte 7K spindles that is going to work as my blob and backup storage. So the question I have myself is, how do I want to design RAID for these 12 disks? I have to think to myself, as a business owner, what do I require? Well, I require hot spares. These hot spares allow me to rebuild my RAID array if I should have a disk fail. And in my RAID 6, I had a disk fail and it wreaked havoc across my entire network. So I need to have a hot spare. Minimum of 1. Okay? So we're going to mark this as a hot spare. And this is going to be global. I could make it for a particular RAID array, whatever, but I'm not going to worry about that for the moment. So based on this 12 drives, I'm using 11 for RAID. So we have to come back over here and ask ourselves, I have this for blob storage that I want to have failover, redundancy, right? So I can't do single, I can't do JBOD, I could do RAID 0, but actually I can't because there's no redundancy. I could do RAID 1, but then I'd have 5 RAID 1 volumes, and they'd all be separate. That's a lot of work and shit I don't want to have to deal with. I could do a RAID 5. So if I think to myself, what do I do with a RAID 5? A RAID 5 will give me the ability of having 10 disks for data plus 1 parity plus 1 hot spare. If I have 10 disks of data, this will give me 140 terabytes of usable storage. That sounds pretty good, right? RAID 5, 140 terabytes, 10 disks, pretty fantastic, right? So let's go a little bit further and say, well, why not just do a RAID 6? In a RAID 6, I'll have 9 drives of data plus 2 parity plus 1 hot spare. Is that possible? Let's see what it says. Data and parity information is striped across all the disks, same as RAID 5, but 2 are used for parity. This means that it protects against 2 failures, but the capacity of 2 disks are lost. So apparently this is possible. 9 disks of data, 2 parity, 1 hot spare. That sounds pretty good. 140 minus 14 is, 126? So I'll still have 126 terabytes of space. But I do have to worry about the computation of 9 disks with 2 parity. I'm not sure I like that. So let's see. I could do a RAID 10, but that'll eat up half my space. And if I do a RAID 10, do I really need to worry about hot spares? But losing half my space, these disks are really expensive. And you have to have an even number, so I'm going to have, with RAID 10, I'm going to have 2 hot spares. So I'll have another hot spare over here, and I'll have 5 disks in a RAID 0 and a mirror. But once again, now I'm not losing half my space, I'm losing more than that. I'm actually using 7/12 of data because of my hot spares. I'm going to be honest, maybe I don't even need to use the hot spares. Maybe I just have 6 subarrays. I mean, I could do that, but I'm still losing half. It's a mirror. It's good. It has good failure protection. They're all striped. Excellent read and write. I mean, RAID 10 might be the ideal for me. But still, I'm losing half my storage space. So let's put RAID 10 in my back pocket because I really do like RAID 10. It loses a lot, but it also gains a lot. In a RAID 50, I have to worry about subarrays. In this case, I can have 3. So a minimum of 3, but I can also do... Actually, no. 3 disks will give me 4 subarrays. 4 disks will give me 3 subarrays. And 6 disks will give me 2 subarrays. But keep in mind, for every subarray you have, you're losing 1 disk to parity. So 4 subarrays, I'm losing 4 disks. Well, losing 4 disks is still better than losing 6. 3 is better than 6, and 2, of course, is better than 6. But now I'm also worried about loss, because I have parity. That parity computation is going to be real nasty. With a RAID 50, I don't think that matters when it comes to even number. So I have, let's just say I have 2 subarrays of 5 each. And then I have 2 global hot spares, 1 for each subarray. This will give me, let's see, 1, 2, 3, 4 parity, 1, 2, 3, 4 parity, and I'm losing 2 hot spares. So I'm losing 1, 2, 3, 4 disks instead of, let's just say, 6 or more with RAID 10. But I still have to worry about computation. Okay, well, how about a RAID 60? These also have subarrays minus 2 times parity. In this case, I want to keep my hot spares here because of parity, right? If I lose a disk, I want it to rebuild. So this still only gives me 10 disks, just like RAID 50 did. The difference is I need to think, okay, RAID 60 is 8 or more, so it's a minimum of 4. If I had all 12 disks, this would allow me to do 3 subarrays. But I have 2 hot spares, which takes me down to 10. So basically, I need to do a 5-disk 2 subarray. 2 subarrays gives me minus 4 disks for parity. Because remember, a RAID 6 is 2 disks. A RAID 60 is 2 subarrays, 2 parities per subarray. That's 4 disks lost. That would be the equivalent of me doing a RAID 50 in this case with 3 subarrays. I'm sorry, 4 subarrays. But remember, with the 4 subarrays, I'm losing parity. Hot spares. So let's see. If I only have 10 disks, five and 5, so I could lose 2 disks with RAID 5 or 4 disks with RAID 60. But here comes the question. In your mind, as an administrator, what is more important? We have to be honest with ourselves here. Do we want redundancy? Do we want speed? Or do we want to worry about cost? These are some of the questions we really have to ask ourselves. Now, with a lot of organizations, we do have to worry about cost because disks can be very, very expensive. With a RAID 10 and potentially a RAID 60, you have a very high cost. With speed, well, this will also potentially be a RAID 10, so it is also a very high, like ultra, because if you go with a 60, you have a little less on the cost. Because a RAID 60, you lose less than 50%, depending on how many drives you have. Now, when you look at redundancy, you're also looking at RAID 10 because every disk has a mirror. But you're also looking over here at RAID 60 and potentially a RAID 50. When it comes to cost, we might not want to look at that because that's very high. If we want a lower cost of ownership, we may look at, the RAID 5 or RAID 6. But once again, with a RAID 5 and RAID 6, you have a lot less redundancy and a lot less speed and performance, especially with a RAID 6 because of computational problems. Keep in mind, with a RAID 60, you also have those computational problems. So at the end of the day, we have to ask ourselves, what's best for what we're using? RAID 10 for virtualization because it's speed, speed, speed. For blob storage, well, now we have to get into, what is the accepted risk of loss. Now, when it comes to the accepted risk of loss, we have to ask ourselves, well, what's most important? Do we risk losing disks, or do we not? This is where other, potentially less expensive items come into play. Now, keep in mind, when you're talking about risk analysis, you can have yourself an array or multiple subarrays, and then you also have to worry about backups. What are you going to back up to? Are you going to be backing up to disk? Well, disk is great because it's good and fast, but you also have to worry about your backups. Well, now we're back to the whole RAID 5, RAID 6, RAID 10, 50, and 60 all over again, because now we have disk-based storage. Disk-based storage is really good, it's really fast, but can be really expensive. Well, what if we back up to LTO? These are tapes. With tape backup, you can store an exuberant amount of data on as many tapes as you want. The problem is those tapes are going to be really, really slow when you talk about recovery. Now, one of the things we have in risk analysis, as we mentioned before, you have, failure rates. Okay, well, how often do tapes fail? Not very often. How often do disks fail? Can be pretty often. Maybe once every 6 months, a year, 2 years. You never really know. But then you also have to worry about recovery point objectives. I believe it's recovery time objectives. and things like that. So what is the recovery point, and what is the recovery time based on that point? So when you look at backups, you have points in time that you save. So you have a yearly, a monthly, let's just say a daily, an hourly, and a real time. Now you have to think about all these different types of backups depending on what type of infrastructure and backup you have. With real time, you need 10 gig connectivity, and you probably need SSD or NVMe. If you're doing hourly, you could probably get away with 7200, 10K, or 15,000 RPM drives. But when you get into the daily and monthly into the yearly, well, a lot of the times LTO is what really matters. But then you also have... So my Camtasia recording crashed. Luckily I was able to recover it, but as you can tell, it wiped out. So let me just finish this up really quick. We were pretty much done anyway. The last thing you have to worry about with storage is this thing called retention periods. Now, a retention period is something you may have to do because of laws and regulations. Now, basically what this means is if you have like litigation, if you have tickets, finance information, HIPAA information, ... you have to save information for a given amount of time. Now the problem with this is you also have to go back to the, well, what are you recording to? Once again, the LTOs are nice, but you might want to make copies of each of your disks. So each disk has a mirror of a disk. Let me rephrase. Each tape has to have a mirror of that tape to another tape. But if you're not doing tape mirrors, you have to do disk with RAID, and of course a potential mirror of that disk RAID. So I mean, that's one of the reasons why I have two QNAPs. So right now I have QNAP O for QNAP old and QNAP new for QNAP new. So basically the new QNAP is going to have the 108 terabytes of disks and 8 terabytes of SSD. All of my backups are going to go onto the old QNAP. So everything that is running in real time will be on the new guy, and I'm going to do backups to the old QNAP. So I will be running things like Veeam. What else am I running? I'm running Proxmox. So Proxmox has its own integrated backup solution. I'm also going to be using what's called QNAP Sync. So basically all of my information on the QNAP, the new one, is going to be synced to the old one. I'm going to be using Veeam for replication and backup to the old system. And I'm going to do the Proxmox backup from the new to the old system. They're both going to be online. One of the nice things about that is if the new QNAP ever fails, all of my critical and, near critical applications, I'll be able to fail over to the old QNAP, and then all my blob data that I really kind of don't care about, I can lose that and, not be affected. For a lot of people out there, you might not have blob data that you don't care about. But, once again, that's where other things like LTOs come in handy. If you have highly critical data, you back it up or replicate it to another disk array, and you do long-term backups to LTO or long-term tape storage. So, yeah, keep that in mind when you're dealing with storage. Having a single storage array, a single vendor, not having tapes. One of the biggest things that I like as a home user, and you might also like at home, is like built-in iCloud. What does Microsoft have? OneDrive. You also have other things like Dropbox. You can also get blob storage from, I believe, Azure and VMware. This is what they call cloud storage, or what I like to call someone else's server or someone else's storage. So basically you're just paying some other guy a bunch of money to store your data so you don't have to store it yourself. Now, when it comes to, once again, risk and finance, you really have to look at this information to see, okay, well, I have 14 terabytes of data that I need to save. Is it cheaper for me to buy 2 small storage arrays and an LTO versus having a single storage array and backing that up to the cloud? Or do you cut out your storage arrays completely and rely on the cloud for all of your storage and, backups? So there's a lot of questions to be had with storage. Hopefully you'll make the right decision. I'm a true fan of, iSCSI. NFS is a big one. I love NFS, and I love Fiber Channel and Fiber Channel over Ethernet because I'm an admin. I like having my gear. I want my Fiber Channel and Fiber Channel over Ethernet storage array because it's mine. I control it. I manage it. You can't fire me because I own it, right? If you move all your storage and virtualization to the cloud, you might save money, but you're also having the potential of losing employees, which we all know it's good to save money, but it's also bad to not have people that know what they're doing. So if you're on the business end, keep that in mind. Saving money in the cloud is not always the best bet, but in some cases it can be a great boon. I thought I had one thing left. I have one last piece of information when it comes to virtualization and storage, and that's something we like to call HCI or vsan. These use something called a replication factor. In this case, I think there's replication factor 2 and 3 in the Cisco realm. I don't quite remember what it is in VMware. But basically what this means is we're going to have, I'm just going to make this small and kind of short. Say we have 3 virtual hosts. Each of these virtual hosts are running something VMware, Proxmox, Nutanix, Hyper-V. You have 3 of them. What you're going to do is you're going to put a bunch of disks in these hosts. Let's just say there's what's that? 6 disks in each host. What's going to happen is you're going to have VMs that live on these hosts. So VM1, VM2, and VM3. All of these VMs are going to live on local storage. And we're going to use this thing called replication factor or redundancy factor, depending on who you talk to. Basically, it's creating kind of a RAID array on your network. Now, I believe Nutanix does HCI and vsan the really coolest way I've ever seen. Basically, you create a RAID 5 or RAID 6, but it's host-based. So basically, you have 3 hosts. This one is going to have 100% of the VM because it lives locally. Host 2 will have 50% and host 1 will have 50%. So if host 3 fails, host 2 will have 50% local and 50% access through iSCSI or NFS or whatever it is. and then it'll normalize it by bringing that 50% back local. And I think that's really cool because you're not losing all of your data. You know, if you have 100% on VM1 and VM2, well, you just lost 100% times 3. And that's replication factor 3 in this instance. So let's say we want to look at it from a Cisco point of view, and I believe a vsan point of view. So basically what this does, we're going to look at VM1. VM1 is 100% on host 1's data storage. It's going to replicate 100% to host 2. That's replication factor 2. If it also replicates 100% of that VM to VM host 3, that's replication factor 3. So basically you have in a replication factor 3 copies of the data. So if VM1 and host 1 should fail, it'll restart itself on 2 or 3 and have an exact replica of data on that host. Now keep in mind, if you have, let's just say, 6 VM hosts and you're running replication factor 3, you'll have 100% copy on, let's just say 1, 2, and 3. But you will not have a copy on 4, 5, or 6. But this is VM1. VM2 may have a copy on hosts 4, 5, and 6. And VM3 will be, somewhere, in the mix. So basically, you're only going to have a replication factor of 2 or 3 across 2 or 3 hosts. If you have 6 hosts, well, you're not using 50% of the storage. I'm sorry, 100% of the storage across the 3 nodes. You're using 50% of the storage across 6. That might not make a lot of sense, but basically you're losing 3 times the amount of VM storage. Woof. I think we're getting on to about 50 minutes, 45 minutes maybe. Anyway, storage in a nutshell. Now, for those of you that are still watching, this is the first time I am using my green screen. I really hope it comes in handy. I plead you, I don't want to beg, but plead, let me know what you think of the green screen. I'm going to try to do something in the background so I don't take up a lot of the screen and I don't have to keep moving myself for certain things. I know I have my mic sitting here that's kind of in the way, so I might want to move that off screen so you can't see it, but it's going to lower my voice a little bit because it's a little further away. So yeah, let me know what you think. If you think I should get rid of the green screen or if I should keep using it, put something else in the background like a beach setting, the mountains, the Sierra Nevadas, Hawaii, who knows. So yeah, let me know. I'll catch y'all in the next one. See ya.